Good day, ladies and gentlemen. I'm Dr. Claudia Elbers, Planet X researcher and professional physicist. And today I would like to talk to you about the total solar eclipse of August 21st, 2017. So on this day, a total solar eclipse will cross the entire United States. The last time this happened was 85 years ago in 1932. However, a total solar eclipse crossed Mexico and the eastern coast of the United States in March of 1970. A solar eclipse can occur when the moon passes between the sun and the earth and casts a shadow on the earth. So a photograph of an eclipse is shown in figure 1. And we can see this is the sun, and the moon crosses in front of the sun, and it obscures the total solar surface. What is left is the corona. So the corona is visible around the edge of the moon in this photograph. And this is what a total solar eclipse looks like. But the moon has to actually have a larger angular width than the sun in order for us to get a total solar eclipse. Also, the moon has to coincide exactly with the sun's position in the sky for the position on the earth where you can see the solar eclipse. And it's also possible to get partial eclipses. These happen more often. And the type of eclipses we can get is, of course, the total, which we are going to get, or supposed to get, on the 21st of August. We can also get a partial eclipse, where the moon covers part of the solar disk, and you may then get a crescent shaped sun at that time. And you can get an annular eclipse where the sun looks like a ring. In this case, the moon's angular width is not wide enough to cover the whole of the solar disk. So the reason why we can get different types of eclipses is because the moon's orbit is elliptical. So it has a maximum distance called the apogee and a minimum distance. And the maximum distance is 406,700 kilometers, or 252,600 miles. And the perigee distance is 356,500 kilometers, or 221,400 miles. Now, the moon size varies for an observer on Earth by 12%. So this is what the moon looks like when it's at its closest distance to the Earth. So that would be the perigee position, and this is what it looks like from its apogee position. So there's a variation of 12%. And now the moon produces, in order for an eclipse to occur, the moon produces a shadow on the Earth. And here we see how this shadow is produced. This shadow is about 70 miles in diameter for the eclipse we are going to get on the 21st of August. And the size of the shadow depends on the moon's position, how close it is to the Earth. So this is how the shadow is formed. We have the moon, we have the Earth. The moon is exactly between the sun and the Earth. And we have rays from the sun. As you can see, this ray coming from the edge of the sun hits the surface of the moon and forms the edge of that shadow there. The total eclipse will be seen inside the shadow. Then outside of that, we get another area where we will get a partial eclipses. And the reason for that is because part of the sun's rays, for example, the rays coming from this side, are in the shadow. But rays coming straight through will still hit this side of the Earth. So we only get partial eclipses in that region. Some of the rays of the sun will get through, and that's the rays from this side. From this side, it won't get through if you're over there. So you will see the sun as a crescent with the moon in front of it. Now this shadow, it's the complete shadow of the moon, is called the umbra, and the partial shadow in this region is called the penumbra. So this is how we get these eclipses. Now eclipses last up to 7 minutes, but the one we will get or we are supposed to get on the 21st of August will last between 2 minutes and 2 minutes and 40 seconds. And outside of the area of the full shadow, which is where you're going to get a total eclipse, you get different variations, which are termed different magnitudes. So closest to that, we'll get, say, 90% eclipse, in which case we'll see 10% of the sun if we were to stand in that region, and so on. Now, because the moon moves and the Earth is rotating, the Earth moves slowly. Well, it seems to from Earth, but it's actually its angular speed is much faster than the Earth's rotational speed because it's much further away from the surface of the Earth. And we're going to actually calculate the speed. But because of the Earth's rotation and the moon's own rotation, the eclipse will move across the surface of the Earth, so it will form a track. And the track that it will form on the 21st of August has been mapped out already. This will be the track. This is the track that will be 70 miles wide. And then outside the track, we will get the partial eclipses. There's the 0.9 magnitude. We will see a 90% eclipse. There will be an 80% eclipse, and between here and there it will vary between 90% and 80%. So the Earth rotates, and therefore it has an orbital speed. We can calculate the Earth's orbital speed using its period. The Earth completes one rotation in 24 hours, so this is its period. So we can then multiply that by the radius of the Earth, given by RE. Omega is the angular velocity, and this gives you the tangential velocity of the Earth. So that is 1,668 kilometers per hour. We can then calculate the moon's tangential orbital speed, which is its angular speed times the distance between the center of the Earth and the center of the moon. So this is what REM represents here. And then we can again use a similar formula. This is 2 pi. 2 pi is the same as 360 degrees divided by the time it takes for the moon to go through 360 degrees, which is the moon's period of 27.3 days. We then convert that to per hour, and we multiply by the distance between the Earth and the moon. And here I am using the perigee radius. So when the moon will look the largest for an observer on Earth. And then we obtain the moon's orbital speed, which is 3,419 kilometers per hour. So as you can see, it's much higher than the Earth's tangential speed. And then, so the moon's shadow will move across the Earth at a distance of 3,419 kilometers per hour minus the Earth's orbital speed, and that gives us 1,751 kilometers per hour. Or, in other words, 1,087 miles per hour. So this is how fast the moon shadow, VSH represents the velocity of the moon shadow across the surface of the Earth. And that speed corresponds to 1.4 times the speed of sound, or Mach 1.4. So it moves extremely fast. Now, the other thing that comes into play with a total solar eclipse is the moon's position. And the moon has to be exactly between the Earth and the sun. And that means it must be in its new moon phase. In other words, we will not actually, even if we were not getting a total eclipse, that would be one of the nights when we would not see the moon at all, because we're looking at it without seeing any of sunlight being reflected from its surface. All the sunlight is reflected back towards the sun. So this is the new moon phase. We can see we have other phases, but the moon has to be in this phase for us to get an eclipse. Then the moon has a period of 27.3 days, but because the Earth is moving in an orbit about the sun, the moon doesn't get back to the same position where we can again get a new moon for between 29 and 30 days. This varies because of the moon's elliptical orbit, so it may vary by 1 day. Now, this period of 27.3 days is called the moon's sidereal period. So this is with respect to the background stars. And the other period of between 29 and 30 days is the moon's synodic period. So that's with respect to the sun. And here this diagram represents the moon and the Earth with respect to the sun, and it illustrates the difference between the two periods. So here is the moon's position where we would get an eclipse. The moon is exactly between the Earth and the sun, so it's in its new moon phase. Then 27.3 days later, the moon is in exactly the same position with respect to something very far away, which we call the background stars. As you can see, it's the same position. But it's not between the sun and the Earth. It's where it was there. But because the Earth has moved, we would need it to be there. So that will take another couple of days. And here in this example, I say it will take 29.5 days, exactly between 29 and 30 days. But it can vary between 29 and 30 days. And so here the moon would be exactly in the new moon phase again, exactly between the Earth and the sun. But it takes a few more days before it can get to that. So this is the difference between the synodic and the sidereal period. Then if the moon and orbital plane and the Earth's orbital plane, which we also call the ecliptic plane, and this is the Earth orbiting around the sun. The Earth orbits around the sun in a certain plane, which we call the ecliptic plane. If these planes were to coincide, then we would expect to have a solar eclipse every 29 to 30 days, because every 29 or 30 days the moon would be in the new phase position, and therefore we would be able to get an eclipse. But this does not happen, and the reason why it doesn't happen is because the two planes are not in the same plane. In other words, the moon's orbital plane is at an angle of 5 degrees to the Earth's orbital plane, or the ecliptic plane. So the new moon phase does not give rise to an eclipse unless it is at a position where the two planes coincide. And the points where the two planes coincide are called nodes. This is the ascending node because the moon is moving upwards this way. And this is called the descending node because the moon would move downwards through that node. So we would need the moon to both be in the new phase position that is exactly between the moon and the earth and to be at one of these nodes in order for us to get a solar eclipse. So this means it doesn't happen every time the moon is in new phase position. It sometimes doesn't happen for quite a few months, sometimes for even years. But if we do get an eclipse, we do know that approximately 18 years later, the moon goes back to exactly the same position it was with respect, and that is with respect to its phase and the position with respect to the Earth's orbital plane. And this period is called the Saros period. It is exactly 18 years, 11 days, and 8 hours long. So if we get a total solar eclipse at a certain point, then 18 years, 11 days, and 8 hours long, we will get exactly the same eclipse. However, it will not necessarily be over the same point on the surface of the Earth. Now, there have been reports of intense preparations by the authorities in areas where the total solar eclipse will be seen. So this is basically in the United States and the cities where this total solar eclipse will pass through. And the excuse that's been given is that there will be a large influx of people wanting to see the total solar eclipse. However, I actually think that the powers that be would be much more concerned with what people might actually observe at this time, because large numbers of people would be looking at the sky. And as we know, there are large numbers of objects in the sky. Most days people don't notice what's going on in the sky. They go about their business, their lives. They don't look at the sky. But when you are expecting to see a total solar eclipse, you tend to look up. And you may just see things that the powers that be don't want you to see. The other thing is that the actual eclipse we are supposed to see is based on the sun, the moon, and the earth being in the correct position, calculated without the influence of the objects that we know are now in the solar system. And as we know, people have been reporting that the moon is no longer in its correct position, and it sometimes doesn't move at all for hours. And people have been reporting that the sun doesn't come up where it's supposed to come up. So if the Earth has tilted, the sun doesn't seem to be at the correct angle, the moon doesn't seem to be at the correct position either, we wouldn't actually get an eclipse. The calculation of where the eclipse is supposed to be is based on the Earth, the moon, and the sun being in the correct position in the sky. And I don't think that's actually happening. So I think what may actually happen is that a fake eclipse will be produced. And they can well do that because I believe they have devices that can simulate the sun and the moon. And these devices are in the sky. They may be in orbit, and say the sun simulator is often what we see when we look up in the sky because it's in front of where the sun is supposed to be, or it's in front of the sun. So they may well use these devices accompanied by their holographic projectors so that anyone with a solar telescope can look up and see what looks like or what seems to be a real eclipse. Now, the other thing that has been happening which concerns this eclipse is that people are saying that it will be a sign of the beginning of the day of the Lord, which is a time of judgment. The Bible does state in Joel 2:31, the sun will be turned to darkness and the moon to blood before the coming of the great and dreadful day of the Lord. However, it seems to me that this requires a total solar eclipse and a lunar eclipse at the same time, which is impossible unless another large object comes close enough to Earth. We cannot have both eclipses at the same time. We cannot have the moon eclipsing the sun and the Earth eclipsing the moon, because it would require the moon to be on two different sides of the Earth at the same time, and that's not possible. So the scenario that we may have then is a large object being between the sun and the Earth and being close enough to Earth to cast a large shadow over the Earth and the moon, and then possibly another object somewhere that is able to cast light onto the moon. And if this object emits red light, then the moon would look red. If this object is large enough, then from Earth we wouldn't be able to see the sun. So it would look like the sun is being eclipsed. So this is one of the scenarios that I think could produce what the Bible calls the sun turned to darkness and the moon to blood. Now, the other thing that has been reported on is that this eclipse will move along a line which almost coincides with this rift, which is called the Missouri Gravity Low Rift. And this crack in the Earth runs across where the Yellowstone supervolcano is, and also where the New Madrid seismic zone is. And there were some really huge earthquakes in 1811 and 1812 in that region. And of course, we know how dangerous the Yellowstone supervolcano is. Now, if we actually get the eclipse that we are supposed to get, it is possible that the moon will exert a certain force on the rift region and possibly lead to some earthquakes. However, the effect would be so small that I tend to believe that it won't happen. Plus, I'm not even sure that there will be an actual eclipse. There may be a fake eclipse. So, I think what is more important is that the effect of the high energy ionized particles that seem to be placing increased pressure on the Earth's atmosphere, and that are coming from the sun and are heavily ionizing the Earth's ionosphere, as well as increasing cosmic radiation coming from the sun, from coronal holes. This is more likely to increase earthquake activity along all fault lines on Earth. And a large earthquake in the Yellowstone area may lead to an eruption, which, as we know, could be catastrophic for the United States and indeed for the whole planet. So, in conclusion, a total solar eclipse is the best chance for observing the brown dwarf stars if we actually were to get a solar eclipse. And we would have large numbers of people looking up at the sky, and maybe a large numbers of people would notice the objects that are surrounding the sun. However, I would think that the powers that be would try to do everything in their powers to hide this from the Earth's population, and they will use anything that they have at their disposal, like geoengineering, which they have been using all the time anyway. They may use their devices to fake an eclipse. They may even use geoengineering to produce such a cloud cover that the eclipse is not visible from most areas where we're supposed to have the eclipse. So, in conclusion, I would say that we should look and see what happens. We should at all times keep looking at the sky and see what's there. You never know. You may catch the objects that are now in the inner solar system and close to the sun. So this is Dr. Claudia Albers, Planet X physicist. Thank you for watching.